Well, we have another question here, question 2. The question says, given the quadratic pattern 5, 10, 17, 26, and the question 2.1.1 says, write down the next two terms of the pattern. So now we're going to do question 2.1 here, and then 2.1.1 says, write down the next two terms of the pattern. So now right here, 2.1.1. We're looking for T1 and T2. So the fact that the question says that this is a quadratic pattern, we understand that there is a constant ratio R, okay? And then the terms are like, excuse me, what am I talking? Well, the question says, given the quadratic pattern 5, 10, 17, 26, write down the next two terms of the pattern. Okay, the question says this is a quadratic pattern. So we're like 2.1.1. We are looking for T1 and T2. Now, we do have terms 5, terms 10, 17, and 26. So quadratic pattern means that quadratic pattern means that there is the second difference of the terms are constant. So now let's see, look at the first difference. Will be 10 minus 5, which is 5, 17 minus 10 is 7, 26 minus 17 is 9, and then the second difference over here will be 2. We can see it's 2 constant. Now we can continue, then find the difference here must be also 2. The difference between 9 and the next term here will be, this term here must be, between 9 and the term here will be 2, so the term must be 11. And then here also 2, the term here must be 13. So there I can find well, we have a question here that says, given the quadratic pattern 5, 10, 17, 26, and then question 2.1.1 says, write down the next two terms of the sequence. Now let's see, the terms here are like, okay, let's just write the question here, 2.1.1. So the terms here are like 1, 2, 3, 4. So we're looking for term number 5 and term number 6. Okay, term number 5 and term 6. Now, the fact that the question says it is a quadratic pattern, we understand by that there is the second difference here is constant, D2. Now, I'm gonna write the question here, the terms here 5. The terms are 5, 10, 17, 26. So we're looking for a term here, and then another term there also, term 5 and term 6. Now, let's first work out the first difference. The first difference here is 5, and then that's 7, and that's 9. Now the second difference, D2, this will be 2, and then 2, we see the constant. Now, what I know the difference between the following terms also in the first difference must still be constant. So over here it must be 9 minus something. I mean 11. Actually, the term here minus 9 will be 2. So that must be 11. Okay. Reason why. Term 5 here minus 26 equal 11. So what should be the term then? In other words, we do 26 plus 11. Okay, this is equal to 37. So this is 37 because 37 minus 26 is equal to 11. And now we can continue some way. we say to ourselves, the difference here must also be 13, because 11 plus 2 must be 13. And then we say over here also, term 6 minus 37 equal to 13, or 37 plus 13 equal to 50. So here it's 50. So therefore, term 5 equal to 37, and term 6 equal to 50. So this is 2.1.1. Now question 2.1.2. The question says, determine the formula for the nth term of the pattern. All right. I'm gonna write. I prefer to move my board over here. And then 2.1.2. Determine the formula for the nth. That's what the question says. Determine the formula for the nth term of the pattern. So, in other words, we're looking for Tn. Okay, and then Tn is given by an squared plus bn plus c. And also, from this formula for the quadratic pattern, we know that A is equal to the second difference over 2. Okay, and then 3a plus b equal to the difference between the second and the first term, and then a plus b plus c must be equal to T1. Now we can substitute the values. The second difference, we did find it earlier. It was equal to 2. Okay, the second difference was just equal to 2. So this will be 2 over 2, and then a will be equal to 1. Over here also, we can use the information we had previously. A is just okay, 3a plus b equal to a has the value of 1, as you find it here. A is 1, and then T2 minus T1, so the difference of the first 2 terms is just equal to 5. So this is 5, and then this will be 3 plus b equal 5, and if I move the 3 over, then we get b equal to 2. Now we have the value of b. Then a plus b plus c equal to T1. So over here also we can substitute the value of a, which is 1, and the value of b is 2. And then T1 is the first term, which was equal to 5. Okay, so we have like a plus b plus c equal to T1. That makes 3 plus c equal to 5. And if I move the 3 over, we have 5 minus 3, which is equal to 2. So now we have like also a, b, and c. Then we can substitute these values in the main formula there, Tn, which will be a is 1, so 1n squared, so just n squared, plus bn, which is 2n, and then c is just equal to 2. So we find Tn. And then the following question is question 2.1.3. The question says, which term of the pattern will have a value of 1765. All right. I'm gonna move my book over here. Let me split this way. So question 2.1.3, we're looking for, when they say which term will have a certain, it means we're looking for n. Okay, the position, the index is the position of the term. So now which term, what is n, such that Cn equal to 1765. Now, we did find earlier in the previous question that Tn was equal to n squared plus 2n plus 2, isn't it? That was Tn, yes, n squared plus 2n, Sn plus 2n plus 2. So we're going to substitute the values of Tn, which is 1.765 equal to n squared plus 2n plus 2. So this means n squared plus 2n plus 2 equal to 1.765. If I move that over, that makes n squared plus 2n plus 2 minus 1.765 equal to 0. And that makes n squared plus 2n minus 1.763. Now, equals 0. Now we can also, how can we solve this? We can do that by factorization, I know, but it can be trickier or longer that way. But I would suggest to use the quadratic formula to solve this. Okay, the formula is given by this negative b plus minus square root of b squared minus 4ac all over 2a. Okay, that's the quadratic formula, because the quadratic equation itself, ax is given by ax squared plus bx plus c equal to 0. Now, in this situation, our variable is not x as in the formula, but our variable will be n. So this will be minus b, okay, plus minus square root of b squared minus 4ac all over 2a. Now we can substitute the values of b here minus b. B is 2. 2 squared minus 4a is 1, and then c is, oops, I don't have, c is quite a lot, 1.765. That's the value of c over 2a. A is 1. Now, there must be two solutions for n. The first one, let's use a calculator. The first one will be just like this, minus open brackets 2 close brackets plus square root, okay, of 2 close brackets to the power of 2 minus 4. A is 1, and then c is 1.765 close brackets all over 2, and then a is 1. Now let's see, did I write this correctly? Oops, not exactly, because no, it's not even 65, but c is negative 1763. So it's negative 1763. So let's correct here. Yes, now when we hit equal, and then we got 41, this is with the positive n equal to 41. N equal 41. Now let's check with the negative also. I'm gonna change this, the plus symbol here by minus now, the minus there. So change the minus, and then when we hit equal, and then we get n equal to negative 43. Negative 43. Now, we must know that n, the indices, cannot be negative, okay, can only be positive integers. So this one is not applicable. So the correct answer is n equal to 41. So this simply means that term 1763, term 41, it means that term 41 equal to 1765. Yes, that's the meaning. Okay. So thank you.